Hi, welcome back to LeetCode. So in this video, I am going to discuss the LeetCode problem. The problem number is 3970 and problem name is shortest path with at most k consecutive identical characters. Okay. So you are given an integer n representing the number of nodes in a directed weighted graph. Okay. Numbered from 0 to n minus 1 because there are total n nodes and it is starting from 0, so it can go up to maximum n minus 1. This is represented by a 2D integer array edges where edges I contain three variables. One is the UI, next is the VI and the WI. That means actually represent a directed edge from node UI to node VI with weight WI. Okay, so you all know about the actual directed weighted graph. So directed means suppose if there are three nodes, suppose node A, node B and node C. So directed means if there is an edge from A to B, that means we can go only from A to B. If there is no edge from B to A, then that means we cannot come back from B to A. Got it? So directed means there is some direction. Okay. And undirected graph means suppose same graph, suppose there is an undirected edge. This is undirected. Okay. So if there is a kind of edge between A and B, so that means we can go A to B and also we can come back from B to A. Got it? So and we actually have edges vector, 2D vector, 2D. So first it is UI, next is VI and WI. So suppose there is an edge between from A to B. So suppose this will be the UI and this will be actually the VI. Okay, and the weight for this edge it is WI. Okay, they're trying to say that now you are also given a string labels of length n, where labels I is the character assigned to the node I and an integer k. Okay, now we have to return the minimum total edge weight of a path from node 0 to node n minus 1 such that the concatenation of the labels of the nodes along the path contains at most k consecutive identical characters. If no valid path exists, return -1. So when I actually found any problem related to minimum path, minimum total cost path, something like that, that means we know that is the algorithm, we actually know that is the Dijkstra algorithm, right? So here actually we cannot actually use that algorithm straightforward because they have mentioned that they've added some condition extra on top of that, that the concatenation of the labels of the nodes along the path contains at most k consecutive identical characters. That means we have to also handle that how many actually same character we have seen till now consecutively. If it's crossing k, if we already crossed the k, that means this is not a valid path. We have to explore another path. But if it is still less than k, if it is less than k, less than equal to k, we can explore the current path. Got it? So if there is no valid path to go from node 0 to node n minus 1, then we have to return -1. I hope the problem statement is clear. So let's see the example 1. So this is actually the example 1. We're actually getting something like that. Okay. Okay, so input first is the n is equal to 3. That means we actually have three nodes. One is the node 0, node n is equal to 3 means 3 nodes. So it is labeled from 0, 1, 2. Correct? Now they mentioned that next is we actually have edges vector, 2D vector. First element is 0, 1, 1. That means there is an edge from 0 to 1 because it is a directed graph. So that's why we can go from 0 to 1. Okay. What is the weight for this edge? That is 1. Okay. Another we actually have another edge that is from 1 to 2. 1 to 2. Okay. 1 to 2. And the weight for this is again 1. Okay. Another we have another edge that is from 0 to 2, 0 to 2, and the weight for this is 3. Okay, and what is the level for this? Level here actually it is A, and this is B, and K is equal to 1. What is the meaning of K is equal to 1? That means we can take maximum one identical character consecutively. Correct? That means, is it a possible valid path? Suppose we actually have, so our target is go to from 0 to n minus 1. That means 0 to 2. Our target is we have to go from 0 to 2. Now suppose we may actually have, suppose 0, then we can go to 1, then we can go to 2. Okay, another path is from 0 to 2. Okay, so if actually follow the first path, okay, so what is the cost or weight for this first edge? That is 1. Okay, correct. Next from 1 to 2, again the weight is 1. Correct. So total weight for this path it is 2. Correct. It is clear. Now we have to check that is it a valid path or not. So what is the level for this node 0? It is actually A. Correct. So this is A. And what is the level for 1? This is again A. And what is the level for 2, node 2? It is B. So it will be look like B. Is it actually valid? No. Why? They mention the K is equal to 2, but K is equal to 1. That means we can place same character, identical character maximum 1 times. So that's why here actually can say that A is present consecutively twice, 2 times, right? So that's why we cannot, this path is not a valid path. Okay, so there is only one path actually left, that is from 0 to 2. What is actually the weight for this edge? This is actually weight is 3. Okay, 3. And what is the level for this node 0? It is A. And node 2, the level is B. So the ultimate, if I actually read this consecutively, it will be AB. So actually you can see that there is no such character that actually identical and placed together that is more than k times, not that is not placed, right? So here actually you can say that only one time, this is also one time. So that's why the minimum weight to reach from 0 to 2 or n minus 1, it is actually 3. Correct? This is clear. Now you actually can see that the expected output is 3. So this is clear. So this is kind of modified. We have to somehow think about some modified Dijkstra algorithm. So we all know about the Dijkstra algorithm. So if you don't know, please first try to read any from blog and try to learn from that what is actually the Dijkstra algorithm. So Dijkstra algorithm, we know our source and we also know that our destination. Okay, so there can be multiple paths. Then there is something, then actually want to go to the destination. Correct? So now what actually follow? That we all know that the source is 0, because we are starting from node 0. Here actually the source is 0. Okay, so also the distance is 0. Correct? Because I am starting from first node, we have not consumed any weight. Here the distance means the weight. We have not consumed any weight because it is the first node. And what is the node? Currently I am in, that is node 0. Got it? Next actually what is the we follow? We will actually check that, okay, whenever we actually check, explore this from this node, current node, from this node, we'll see that, okay, from 0, from where actually I can go. Okay, suppose this is xi, this is x1, suppose x2, x3. So we'll see that, okay, if I go from 0 to x1, okay, so what is the weight? Suppose weight 1, w1, this is w2, and this is w3. So we'll see that, okay, so from source node in this current node, how much actually weight I have consumed? Suppose this is w. Okay, w weight, total weight I have consumed from source to this current node. Okay, this can be suppose y. Okay, so now to reach from source to this current node y, I have consumed weight w. Correct? Now if I want to go x1 from this current node y. So what will be the weight I have consumed to reach node x1? It will be w plus w1, correct? And now if I assume, I actually choose that I want to go to x2 from this current node y. So what is the total weight I will consume to reach to x2? That will be w plus w2. Got it? Similarly, if I want to go to the node 3, x3, so total weight I will consume, that will be w plus w3. Got it? Ultimately, why I actually add this? Because our target is to overall minimize the overall weight, total path. Not like we actually go to the minimum path from this current node to the next node. Never no. We want to go, or we want to reach the destination from the source node by using the minimum total weight overall. Got it? So that's why whenever I will take the minimum of all the paths. Suppose, let's explain another way. Suppose we actually have this node. So this is actually the one path. Next is this path. Next is suppose this path, then again this path. Okay. So ultimately I want to reach, this is our source and this is our destination. So I want to reach from this source to destination by using the minimum weight, minimum total weight. So that's why I will actually choose what is the minimum weight to reach to this. What is the minimum weight to reach to this? What is the minimum weight to reach to this? Then I will see that, okay, by here actually you can see that suppose x1, x2, this is suppose x3, x4. So I'll see that by which minimum weight I can reach to this node. Okay, one possibly x1 plus x2, another will be x3 plus x4. So I'll choose whatever the minimum out of these two option. So from that weight I actually try to reach to the destination. Got it? And ultimately after here actually you can say there are two options, right, to reach destination from this one path and from this one path. So I'll see what is the minimum weight. Suppose here actually it is suppose x5 and this is x6. I'll see that what is the minimum of this. Suppose mean plus x6, this is for this path and this is for one other path. Got it? So I hope this explain what is the overall in a short way to recap actually what is the Dijkstra algorithm. Now how can actually use that generic Dijkstra algorithm here in this problem, in our problem. So we know what is the source. It is always 0, and destination we know that will be n minus 1. Got it? And we all know to get the actually minimum distance to reach to the any node. So I actually use the priority queue. And to know that what is the minimum weight I have used, so for that I actually need one vector. So that will actually indicate the distance or weight to reach the any node. And I'll start from positive infinite value, right? Positive infinite value. Now, so in our problem, what is the extra actually we need to follow to reach to the destination? So first of all, we need to know that how many times we have seen the current character, correct? So for that we need one counter, correct? And we need to know what is the last character. Why actually we need to store the last character also? Because suppose currently this is our current node, okay, and level it is suppose B, and from this node it was actually level as A, correct? So I know that till this node the counter or consecutively I have used 2 times. Suppose again actually we have another node that is A. So for this node, what will be the state look like this? Counter will be 2 and last character it will be A, because I have already currently in character like node A, level is A, and how many times actually I have used, that is 2, correct? Now if I want to go to this node from this current node, so then I have to also follow that counter of the consecutive node that should be less than equal to k. If it is already greater than k, this is not a valid path, I will discard this. I will go to the next node. Okay, so that's why I'll see that, okay, current node level is actually B and previously it was A, so this is actually AB, right? So our counter will be reset to 1, correct? I'll see that, I'll check that this actually less than equal to K or not. If suppose it is actually, instead of B, it is suppose again A and K value suppose 2. Okay, let's understand this situation, or actually till this node. So what is actually the state? State will look like counter will be 2, because I have already seen this K A 2 times consecutively, correct? And what is the last character? A, correct? This is fine. Now if I want to go to this node, or actually it is labeled as A, it is also labeled as A, and what is the K? K value is 2. So maximum 2 times actually I can use the identical characters consecutively, correct? So K indicates that value or that meaning actually. So what actually I will see, okay, so if I want to go to this node, so it is also labeled as A, so counter will be 3. So how actually I can use that, how actually I can calculate this counter will be 3, because the previous character, last character, it was actually A, and which is also same as the current the never level of the never node. So that means it will be counter plus plus whatever the actually counter it was till the previous node, so it will be actually the 3. Okay, now actually I'll see that, is it less than equal to K? So if it is less than equal to K, that means we can go to this never node. If it is greater than equals to K, I can't go. Sorry, greater than K, not greater than equals to. If it is strictly greater than K, then actually we cannot go to this never node. Got it? So that's why what actually you need to store in the priority queue, one is the weight or cost. Then what is the last node? Then strict, how many times consecutively we have used the identical characters. Okay, and what is the last character? So these 4 things actually we need to store into the priority queue. Got it? So we now actually we know that how actually we can use this information to calculate the next smallest or the next possible smallest never we can actually go from this any current node. So I hope this is clear till now, that why you need to store these 4 things. These 2 actually used for any generic Dijkstra algorithm in any, right? And these 2 are extra in this our problem, because we need to follow the condition that the consecutively we can actually use maximum K times. So this should be less than equal to K, and for that we need 2 information, what is actually the last trick and what is the last character. Got it? Now in priority we have to store this, correct? Now just go to the code. I hope this will be clear. So this is the first version of the actual code that actually I implemented during the contest. But anyways, I got the actually memory limit exceed. I will explain why actually this solution will give us actually the memory limit exceed, and also I'll actually later after that I'll also explain how to optimize that. Got it? So first of all, from this edges vector, I'll create actually the graph. So we all know that we actually have a maximum n nodes, and it is anyway marked from 0 to n minus 1. So that's why I'll create a vector of pairs of n size. So from u to v, and there will be some weight for that edge w u to v. So that's why our key will be the I0, that means the u, and we can go to the vi, so I1. Okay, and weight for this current edge, it will be I2. Correct? In this order they mention that first is the EY, the source node, VI is the destination node, and wait for this current edge. So that's why in the pair I will store this, what is the V and what is the W. Got it? So first of all, after this for loop we have created the graph. How should it will look like this? Correct? Now actually in Dijkstra algorithm we all know that we also have to store the distance. Why actually need this vector distance or weight to check that whatever the neighbor actually I can explore from this current node, is it actually optimal? Suppose we have already explored, suppose there are 2 paths to reach to this node. Okay, so suppose in this path we have already explored that this weight is W1 and this is W2. If I explore this path, if I want to reach to this node from this path, this second path, it will take weight as W2. If W1 is already less than W2, less than equal to W2, So should I explore this path also again? No. Anyways, our target is to, we don't need to the total, we don't need to track the path. We need to track the total weight, So if it is in this path, same as it is in this path, right? Ultimately, we reach this with the same weight. If it is smaller than that, if W2 is less than W2, then actually we need to explore this path. We should take this path, right? Because this is the optimal path. Got it? So that's why we need to take this vector. Actually, I will store that for this state. What is actually makes minimum weight we have seen till now. So if it actually one more optimal path, so I will take this current path and try to explore the next possible path to reach to the destination. Got it? So if it is already we have already explored the optimal path, so we don't need to explore the current state or current neighbor. So we will actually discard that. Okay. So for the distance, what is the value actually need to store? First is what is the node number n. So how many nodes are possible? N nodes are possible, and to reach all nodes or each or any nodes, we need actually have two different state. Why? Because there can be what actually need to store. How many actually maximum? Sorry, this will be 26. Okay, this will be 26. I hope, I don't know, actually I have written 29. Okay, got it. So any node, suppose ith node, I can use k and the character. So I needed three state, actually 3 state means 3 state variables. It will be more clear. Three states variables. Why? First is the node I have reached. Okay, current node I have reached. This k indicates that second state variable actually indicates that by how many consecutive, or what is the strict numbers, strict value, or how many times actually consecutively we have used the same character to reach this current node I. Okay, and what was the last character that I actually used? Okay, so if I already used this state, same state, so that means we don't need to explore the same state again. Correct? So that's why I needed the 3 state variables. Got it? First is the node number, then k is the strict value, and the last character I have actually used. Got it? So that's why first value, it can go up to n nodes are possible, so that's why it will be n, and each node I can actually reach by using maximum value of k. Correct? So that's why I will actually take k plus 1. It can value go up to k plus 1. Clear? Why actually k plus 1? Because this problem allowed me to have maximum k number of consecutive identical character. So that's why it may possible that I have actually consumed 8 k number of identical characters. So that's why our state can go up to k. So that's why k plus 1. And what is the different last character possible? That is a to small z. So that's why it can go up to 26. But sorry, here I have written 29. But yes, it can go up to 26. Got it? Now we need to priority queue to get the next smallest node we can reach from the source. So for that actually we need 4 variables. Actually 4 variables. First is the weight anyways. So we want to sort according with respect to the actually weight. Next is the node number of so what is the node number we have reached? Okay, and this third one is the strict number. So how many consecutively, how many times we have used this identical character consecutively. Got it? The next is the what is the last character? It will be between again 0 to 25, means small a to small z. Correct? So this is clear. So here actually I also commented that first is the first indicate the cost, then next is the node number, and the strict mean how many consecutive type I have used, and the last character I have actually used. Okay. So we all know they mention the source node is always 0. So that's why we all know the starting node will be 0. So that's why the last character it will be labels of 0, whatever the node 0 actually represent, minus a. So to convert this to an integer. Okay. So now here actually you can see that initially before starting of this our Dijkstra algorithm, we need to make the starting node the value distance as 0 or weight as 0. So that's why weight for this node 0, streak value is 1 because I actually used this one character, and the character that actually I used last time, that will be 0 because this is the first node. I am starting from this node, so that's why our weight will be 0. I have not any consumed any edge till now, so that's why our total weight for the edge from the starting node, it will be 0. Clear? Now I'll store this into this priority queue. So this is 0 means that weight till now weight is 0, and this node is 0, and how many times I have used this current last character? Only one time, and the last character, it was actually this level 0 minus a. Clear? Now actually to start the priority queue, till actually our priority queue have some element, I'll continue. So that's how while loop will run till actually have some element in the priority queue. So first of all, I will pop from this priority queue. So I'll get 4 things. One is the cost for this current node, or what is the total weight I have to reach this current node, and what is the streak number, and what is the last character, and pop this from this priority queue. Now if I have to explore another path, currently explore the second path to reach the same node, so that's why I will say that this is actually optimal path or not. If this is not optimal path, we don't need to explore the never, because this is anyway not the optimal path. So that's why I'll see that what are the current cost actually to reach the current node. I'll see that whatever the distance actually I have in the distance vector, if it is greater than that, that means I'll continue. This is not our optimal path. Got it? We have already another path. We have already explored another path that actually is optimal path, means within smaller weight. Got it? So I'll continue. If this is actually the optimal path, then actually see that, okay, have we reached actually the target node? So target node, what is our destination? Destination is the n minus 1. So that's why I'll see that what is the current node? It is equal to n minus 1. That means this is actually the destination. So whatever the cost actually I have, that will be returned. Correct? Else this is in between, something in between any temporary node. So that I will see that what is the never nodes actually I can go from this current node. I have to explore that. So that's why I'll actually iterate the adjacent list of the current node. Okay. So I'll see what is the next level character I want to go. What will be that? The level of the never node. So that's why whatever the never node actually I have, I'll actually see what is actually the character. Got it? And new streak, it will be actually check that either it will be increased by 1 or it will be reset to 1. So when it will be increased by 1, if the last character and the current character it is same, new character and the last character, the current character and the last character is same, then actually I will store the streak plus 1. Got it? Or else if it is different, not equal to the last character, so that then it will be our streak count will be 1. Okay. So before actually assume this is actually one possible answer, I have to see what we have to follow one condition, that whatever new streak actually I have, that should be less than equal to k, because they have allowed maximum k times. So let's see that whatever the streak number that is less than equal to k, then actually one possible value. Also we have to check that whatever actually the value actually I have currently, distance or weight to reach to this state or the never state. So if it is less than that or if it is greater than that, then actually we will explore this this current path. Otherwise, if we already have explored the never node with an optimal path, then we don't need to explore the current path. We should discard this. So that's why we'll see that whatever the actual weight we have till now, we have seen till now to reach to this never state. So if it is greater than the current cost or current weight, what are the cost to reach to the previous node and to go to actually this current node? So that will be added. So cost to reach the previous node plus the current weight of the current edge. Got it? So it will be added. So if it is greater than that, so we'll actually explore this current path. So that's why we'll actually first store this value into this state for this never state, and store this also, insert this into this priority queue, because this is one possible answer, and store this into the priority queue. Got it? Ultimately, if we have not reached this state, that we have not ever reached to actually the destination, that means there is no valid path to reach to actually the destination from source. So that's the ultimately return -1. Got it? Now why actually we will get, so I hope this is actually clear. Now why actually I will get memory limit exceed for this in this approach. Why? So actually you can see that we actually taken one vector distance dist. So what is the size for this in the worst case, what will be the size for this vector? So n into k plus 1 into 26, right? There are 3D vector. So this will be actually the n, this is k, and this is actually the 26. So n value can go up to maximum. Actually, you can see that. So 5 into 10 to the power 4. K value can go up to maximum. K value is equal to 50. And this is 26. So what will be actually the 10 to the 5 into 26? So if I roughly assume this is 25, so it will be 625 into 10 to the 5. So it will be kind of, if I assume this is 10 to the power 3, this is 10 to the power 5, it is 10 to the power 8, this is greater than 10 to the power 7, right, roughly. So that's why I am actually getting memory limit exceed during the contest. Got it? So how to optimize this memory? So here you can see that ultimately what is the range for this. So anyways, there are 3D vector, right? Just of n, k, and the 26 different characters. So anyways, we cannot optimize this. This we cannot optimize because there are n different nodes. Now actually we need to think about these two, k and 26. So if I can actually merge this into a single variable, then actually it will actually work fine. How? So k into 26, k value can go up to 50, correct? It can go up to 50, and this value can go up to 26. So to represent 26, how many bits actually required? So one represent 0 and 1. This one, okay, 1 minute, 1 0 0. This will represent maximum what? 1 1 1. So this will be 1 plus 2 plus 4 plus 8. This is maximum value. Actually, I can represent by using 4 bits. That will be 15. Cut 15, but it is still 26. So that's why I need actually 5 bits. Correct? 5 bits. So if I actually resolve any 5 bits in a single variable, that will represent what is the last character. Correct? Correct. And for this k, maximum it can go up to 50. So to represent 50, what is the maximum value actually required? How many maximum bit actually required? 1 plus 2, 4 plus 8 plus 16 plus 32. Okay. So let's see. 1 plus 2, this is 3, 3 plus 4, 7, 7 plus 8, 15, 15 plus 16, this is 31 plus 32, that it will be 63. So this is enough to represent the 50. So how many bits is required to represent this k? 1, 2, 3, 4, 5, 6. 6 bits and 5 bits for this. So anyway, it will represent in one single integer variable. Correct? This is clear. So I can actually use a map for this. First map for each state, each node. So there will be n maps, where key it will be the last 5 variables. It will indicates the last character, and rest of this bits will represent the k. Got it? Now what is the code? So let's say I have just changed the distance variable. You can see the distance vector. I actually used n another map. Okay, for each node actually used on another map. So what will be the key for this map? One will be what is actually the k value and what is the last character, right? So how to use that? Just see these 2 lines, then it will be easy to understand. So how actually get the last character? We know the levels 0, whatever the levels of the first node 0 and minus a. So this is still the value. So what will be the key for this current node? So first of all, this one, why actually I am shifting this one by 5 bits? Because this one is the strict number, right? Actually you can see that what is the difference. What is the strict number initially? 0, 1, previously it was 0 comma 1 comma ch, correct? Now I know the last 5 variables, last 5 bits, it will be for the last character. Okay, so that's why first of all shift the this value 1 to this by 5 bits in the left side, and then take the whatever the last character. Got it? This will be the 0 and this will be your key. Clear? First of all, I know the streak value is 1. So that's why first of all shift this to by 5 bits in the left side, and then take the OR value in the so this character value, it will be actually placed into the whatever it will modify, it will be actually modify only the last 5 bits. Got it? So in this I will actually generate the key in this modified distance vector. Got it? In the same, when I'm trying to find the next characters, in is actually check the same thing. When I'm trying to new key, what will be new key? That will be the new streak number. Actually we can know, we can calculate that what are the new character and the last character is the same. If it is same, then actually it will streak plus plus, or it will be reset to 1. Got it? Again I have to generate the new key. How actually whatever new streak value, that will be shifted by 5 bits in the left hand side and take the OR of the last character. Got it? Similar way, when you are trying to generate the current key for this current node to see that this is actually optimal path or not. So that time actually also generate the key for that. So how actually you can calculate the key? So whatever streak currently I have to reach the current node, first of all shift to the left hand side by 5 bits and also take the OR with the last character. That actually store into this priority queue. Got it? I hope this is clear. Just try to explore this way to optimize this. So I have shared this in the description, you can check that. If any doubt, any suggestion, you can comment on that. And if you like the experience, please like the video. And if you are not subscribed, please subscribe channel. Thank you. See you in the next video. Bye bye.